Hello students, welcome back. In the previous video, we went through an example on homogeneous equation. And I hope one example is enough, but in case it is not, let's do one more. So this is a standard form. And we're doing this problem now. Let's look at each term. Second degree, second degree, second degree, and this is first degree times first degree, so that too is a second degree. Everything has the same degree, so this is homogeneous. Now, look at this standard form. I want y prime. Here, I have dx and dy separated out. So I'd like to express it in terms of y prime or dy dx. So let's go ahead and do that. Here, independent variable is x, so let's divide by this. Okay, we have this. And as you can see in this standard form, I want the derivative equals to something, so I have to solve for this dy over dx. So let's flip this one to the other side and then divide. So you can have something like this, negative of this after flipping. And then we can divide by this. And there you go. Let me expand the font a little bit. Okay, we have fractions, so I'd like to have bigger font. A little bit of simplification is in order, I guess, because I have too many negatives here. So numerator is okay, x squared plus y squared. How about the denominator? We have negative up front, another negative here, so let's put xy minus x squared. Okay, that looks better. Now we have to make some adjustments so that we have y over x. Here, independent variable is x, not t, so we need y over x. How do I get y over x from here? Divide each term by x squared. So divide by x squared, so I have 1. Divide by x squared and have y over x. That quantity squared. And then divide by x squared, I get y over x. Finally, divide by x squared, I have 1. And look at this. We have a function completely out of y over x, which I'm highlighting in red. And that's the substitution I'm going to take. V is equal to y over x. Well, you know what? I'd much prefer to expand entire notebook here rather than expanding line by line repeatedly. Okay, let's do this. Y equals to v times x. And then let's take the derivative. Y prime is equal to, let's see, product rule, v prime x plus v, and then the derivative of the second function, but derivative of x itself, that's just 1. So here we go. And as highlighted over here, v is y over x, and then y prime, this one, the derivative, is gonna be v prime x plus v. Okay, ready? Plug everything in, and this is what I'm gonna get. V prime x plus v is equal to 1 plus v squared over v minus 1. Let's see, did I get everything here? This part. This is v, so 1 plus v squared in the numerator, and then v minus 1 in denominator. Looks good. And here, this derivative by product rule is v prime of x plus v, alright? But then again, I prefer to have this dv dx notation than this one, so let me rewrite it like this. And it's more customary to have x over here than it right, so okay, ready? Almost done. If I flip this to the other side, I'm gonna get all the v's on the right hand side so that I can divide them away. So here we go. How do you like this? Okay, all right. And some simplification is in order in the right hand side. Okay, that. And minus 3 times v minus 1. After breaking out those parentheses, what I get? I get v squared plus v. Did I do this right? So after canceling those out, I'm getting 1 plus v, or let me write it as v plus 1. Oops, what did I click? Wrong key, sorry about that. V plus 1 over v minus 1. Okay, x dv dx is equal to a function of v. So we are ready. Let's take the separation of variable to the next step. Divide whole thing and divide this one. So v minus 1 over v plus 1, because I just divided, I need to take the reciprocal. V minus 1 over v plus 1. And dv is equal to, now dividing these away, 1 over x dx. Good. Let's take the antiderivatives. This is homogeneous equation, so right hand side I'm getting log of x plus c. Left hand side is going to be a bit of a problem. No, not really. It's not too much of a problem. Numerator also has order 1, so you can divide by denominator and get quotient and remainder, or you can simply do this. And then, let's see, what is this integral in the left-hand side? V plus 1 over v plus 1, it is nothing more than just 1 that's what we get. So from here, quotient is 1 and the remainder is negative 2. So yeah, you can do that through division. But I decided to take a little bit clever path here. Plus 1 and then another minus 1 so that we get 1 minus 2 v plus 1. Okay, let's complete the derivative computation, or excuse me, antiderivative computation. V minus 2 log of v plus 1. What did I click? Equals to log of x plus c. Okay, that's what we have. And then over here, I can always flip this coefficient 2 up over here, so that I don't have to worry about inside of the logarithm becoming negative. Why do I have this extra one here? So v minus log of v plus 1 to the quantity squared is equal to log of x plus c. And let's put some space in between. Is this enough? I guess so. I guess this is enough. So let's copy and paste this whole thing and rewrite everything in terms of y over x. And then this one is that looks okay to me. Yeah, this is a solution, implicit solution, but yes, it's a solution nonetheless. There's still something that bugs me because of this log of x. X is always positive here. Is there any way to improve this? From this point on, it is mainly style point. Okay, flip this logarithm to the right hand side. Then plus log of 1 plus y over x squared. Okay, that's what we have. And then let's see, getting these in common denominator, I have x plus y over x instead of this. Okay, and then combining this logarithm and that logarithm together, into a single logarithm. Let's see, log of x times this. So what we have x here, and then this is x squared. So if you simplify this thing, you're gonna get y over x is equal to log of x plus y, total quantity squared over x. This is not much of an improvement. Yeah, this is not much of an improvement compared with what we have over here. Okay, so let's just remove all those and let's just go ahead with checking. All right. Y of x over x minus log of y of x over x plus 1 whole quantity squared equals to log of x, I've got capital, plus some constant c, and this is the equation, and take the derivative with respect to x. That's what we get, and then solve this, the previous result, with respect to y prime of x, This is what we get. Negative of x squared minus y squared over x squared minus xy. Is that what we have over here? Indeed, yes. Well, actually, same as this one. If you simplify by taking negatives of both numerator and denominator, we get that. Yes, everything fits, and this is correct.